Hello, everybody. It's yet another Thursday. It's Thursday, the 24th of November, which means if you're in the United States, it's Thanksgiving. So, as the majority of our team here at Redis Developer Relations is in the United States, I'm expecting a quiet day, but we're going to stream as normal today here from the United Kingdom. So, welcome. This is Simon's Things on Thursdays, where we talk about running Redis with IoT devices, maybe some hardware, or we look at lower level concepts like the network protocol we've looked at before, or how certain data structures work. Sometimes we do multi-week projects that take a couple of streams, and we are currently sort of 50% through one of those. So what I wanted to do quickly was sort of recap where we're at, what we're up to, in case you missed the previous streams video. If you did miss that, go ahead and watch it on our YouTube. You'll find that all of these streams end up there on the Redis Inc. YouTube channel. So you can always catch up on what you've missed. That applies to me and the other staff members that are streaming at the minute. So you might want to go catch Justin's show where he's looking at a large amount of data to do with bird sightings and JSON, and Savannah's show where she's currently working with the GitHub API. So yeah, find us on YouTube. If you like to watch us live on Twitch, we're also on Twitch. So down there, things live on Twitch for a couple of weeks after they go live or after they go out. And on YouTube, they're kind of there forever. And then the other way that you can get in touch with us, and especially this show, as we have our own channel, is down there on the Redis Discord. So you can go discord.gg/Redis. And get to our community, talk to all the other folks in the developer relations team, but also talk to thousands of other Redis developers. And we have channels for pretty much every single topic you could think of. So all of the Redis University courses, different programming languages, live stream shows such as this one, and just sort of, general show us your projects or tell us what you're doing or upcoming events. Yeah, we love to hear about those things. So yeah. So let's take a look at where we were and what we're doing here really quickly. So we are, I'm just going to bring my desktop in here. We are currently in the middle of a project that I have not yet written any documentation for. So we are looking at counting things with Redis, which is on the face of it quite an easy task to do, especially as we're taking the easy option here. We're not looking to be counting distinct things. So we're not looking at like how many different vehicles have I seen go past my camera or something. That's a slightly different problem that you'll have seen us look at before, where we talk about sets and then the probabilistic data structures. Here we're looking at just how many times has this thing been pushed around? So like it's a turnstile to go into an event or something. We don't care if it's the same person come in 3-4 times because they've gone out to the parking lot for something and come back again. We just want to count. So if that's easy, why is it taking a multiple week stream to talk about that? Well, what we want to do is we want to count in a way that if we have multiple interfaces contributing to the count, so say multiple turnstiles, they all need to display the current count of how many people are in the venue. Say it's a fire limit or something, and the stewards need to see that. And they need to stay in sync with each other. So when somebody else updates the count, I need all of my interfaces to update. And that's kind of the complexity that we are working with here. So last week we looked at, we've got a web folder here in the GitHub repo. And I will just show you really quickly where to get this. If you are interested in following along, I'll put this in the show notes afterwards as well. So we have a GitHub repo here. We have 2 folders. We have web and Raspberry Pi. In the last stream, we looked at web and we wrote a node interface. And what that does is it uses the Redis incubi or incubi command to add 1 to a counter in Redis. And then it uses Redis Keyspace notifications to propagate out that that key has changed and that we need to do something about it. And then all of the interfaces subscribe to those notifications, and then they pull back the value and update it. So let's quickly take a look at how that's going to work with the web interface here. So I'm just going to start this up, and we'll look at some code afterwards. Let's go npm run dev, I think it is. I think I put node 1 on this one. Yeah, we did. Okay, so we've got a server at port 5000. So I'm going to start localhost 5000 here, and we've got really simple front end. So what this is doing is it's telling me that the current value of the counter is 39, and I can increment it 40, 41, 42, etc. And what you'll see is kind of what you expect. You know, you increment it, you get one more. What's backing this is, let me go into Redis here. I've got Redis Insight. There's a single key in my database. It's called my counter, and it has a string value. And we seem to be having a bit of a slow network here. And it should have a value in there. But let's just come out of that and start again. There we go. Right. So we've got 44 in there at the moment. 44 matches with what we've got in the interface. If I change it to 45, what we'll see when we refresh this, or we can turn on auto refresh, is we get 45. So simple counting. The complexity we were looking for was, well, what if we add like a second turnstile or a second interface here? So this gets 45. What I want to happen is when I click this one, 46, you see the other one changed to 46 as well. And obviously, when I go back to Redis here and refresh that, 46. So the complexity we were looking for was that these two or many interfaces can stay in touch. And that was kind of where we got to last week, was we now have a mechanism for doing this. So how do we do that? I'm going to attempt to draw that for us now. So let's see how that goes. How we do that is, let's swap to the iPad here. How we do that is I've chosen to use server sent events for the node code. So it looks something a bit like this. I'm just going to try and draw it. So we've got okay, we'll have Redis in green. We've got Redis here, and there's our current count. And then we've got our node application here. And what that's doing is servicing potentially multiple front ends. And when those front ends, somebody presses the increment button, we send we hit a route on the back end. And then from there, we do an increment on that counter, and then that becomes 49. And then what we've got to make sure that they stay in sync is that Redis will be, or Redis is watching this key here, point counter, and it emits a pub/sub notification whenever that key changes. So whenever something happens on that key, we broadcast a pub/sub, and we don't know who's listening. And one of those things that's listening is the node application. And the node application then uses a technique called server sent events that is like a one-way WebSocket. It allows us to push data back down to the front end here. So 49 gets pushed down here, and then 49 gets displayed. So that's what we have. That's our current architecture. What we're going to try and do we are going to do in this stream, because I've kind of already done it. We're going to walk through how we did it. I'll change colors here. We're going to add another front end. We're going to add a Raspberry Pi, and we're going to give it a red reset button and a green increment button. And we are going to use what's called a 7-segment display. And we are going to have the Raspberry Pi then also increment the value, and then also listen to these subscription or for these pub/sub messages. So what you'll see is when this value here gets updated, so say it becomes 50, then what's going to happen is a pub/sub message goes out over here, it goes out over here. That causes the new value to be sent down to here, and it becomes 50, 50, and 50 there. So here we can see that we've got multiple interfaces that are implemented differently. So the Raspberry Pi is hardware. The Node interface is software. It's just a web browser. The Node interface deals with having multiple instances of itself through server-sent events. So it subscribes once to these Redis pub/sub events. The Raspberry Pi subscribes once per Raspberry Pi. We've only got one, but we could have multiple. And they all stay in sync like this. And actually what happens when we get the pub/sub event is it doesn't tell us what's happened with the key, or rather it does tell us what's happened with the key. It tells us there was an increbuy operation or a delete operation if we are hitting the red button and resetting the count. But then we have to go actually get the value of the key. So these interfaces will also do a get on that key to get the new value, and that's how it knows what to display. So yeah, we've got a bit of a interesting architecture going on there. In order to do that, I've had to turn on Keyspace notifications in my Redis instance. So what you'll see if I start up the instance here and I do something like git config set notify Keyspace events. No, not set. I'm getting it. Config get notify Keyspace events. You'll see that I have G, $, and K. That's a bit of a cryptic string. We explained it in the previous stream, but basically what it means is I'm interested in global events. So commands like del for when I get rid of the counter. I'm interested in key space events or key events. So things that happen, I want to know by key rather than by command. And $ is, I think, string commands. So yeah, we do that and we subscribe to those events for that key, and we'll look at that in a second. And that's how we get told what's going on. So let's quickly look at the Node code for this. We are looking at the wrong thing here. Here we go. So let's make that a little bit larger as well. So the Node code for this is, we ran through it in the previous stream. It's fairly simple. It's an Express application. It has a single key in Redis called myCounter, and it listens to Keyspace events. So __ Keyspace on database 0, which is the only database you should use, for that key name. So we're listening to things that happen for that key. Because of the way that Node works, we need a second Redis connection to basically do the blocking pub/sub commands. So we have two Redis connections going on, and then we just have some simple routes here. So if I hit that increment button, it just increments the counter by 1. That actually returns the value of the counter as well, but we're not using that because we need to broadcast it to multiple interfaces, not just the one that incremented it. So we're just returning OK. Similarly, if I reset it, I just delete the counter, and again, we get OK. We don't actually care about sending a 0 back. That's dealt with by another mechanism. So whenever the front end starts up, it subscribes essentially to this /count route, and that's going to use something called server sent events. It keeps a long running connection, kind of like a one-way WebSocket. And then whenever something happens, we can push data down that, and that's how the front end gets updated. And let's see how this works. So we then connect to Redis in a couple of places. We need a connection for running commands, connection for pub/sub. And here we subscribe to those messages that we're interested in. So the ones for that key. And if we get a delete message, the new counter value is 0, which we kind of use as a default up here. And if we get any other sort of message, we're going to go and get whatever the new counter value is. And then we're going to loop over all of our front ends that are listening. So all of those subscribers that want a server sent event, and we're going to push a server sent event out to them. So that's how the Node code pushes things out. So there's one subscriber to Redis, and then it yields multiple pushes out to different front ends. So that's the Node code. For the Raspberry Pi code that we want to look at today, we're not writing it in Node. We're going to write it in Python. We've written it in Python. And we are going to use something that looks like, got a picture of it here, this. So we have this thing called a TM1637. It's what's called a 7-segment display. So each of these digits here comprises 7 different segments that can be turned on individually. Each digit can be addressed. There's a sort of colon symbol if you want to build a clock and have it flashing per second or whatever you want to do with that. And these are really, really common bits of hardware. I think I got mine off of eBay, but you can pick them up anywhere. Some of them have this connector that you see up here on both sides. So you can chain them and build longer displays. The one I've got has that, but we're not using that feature. And they have 4 different connections here, and we'll look at why that is in a moment. So what are we going to build on the Raspberry Pi? We need to build a front end using this, and also we need some inputs. So we need some arcade buttons for that. And I will just attempt to draw what this might look like. So let's start a new drawing and get rid of these. So if we've got our Raspberry Pi is represented by this blue box here, what we're trying to build here is a couple of things. So we need a front end, and we need some inputs, and we need some software. So let's get Redis in the right color this time and use red. And we need to talk to Redis. So we're going to build some software. The software we can represent as this here. That's going to be Python. And it's going to do a couple of things. It's going to use Redis Pi to talk to Redis and subscribe to PubSub notifications. It is also going to talk to the Raspberry Pi's what are called GPIO pins. So these devices have what's called GPIO pins, general purpose input output. They're kind of the Raspberry Pi's interface to physical computing. So the way that we can connect other things to it, you can plug things in. If you're feeling brave, you can solder them directly. If you want a reusable Raspberry Pi, it's probably best to just get some wires and plug them in. So I've done that with a couple of things. So I've got a couple of arcade buttons. So we've got a nice red one here, and we've got a nice green one here. And then we've also got the TM1637 display that looks a bit like this. It has these digits on it, and it has 1, 2, 3, 4 connections. So I will post a proper wiring diagram for this when I write the README up, but for now, basically what we need is each of these buttons needs 2 connectors. It needs to go one to a GPIO pin, so that will basically tell us when the button's being pressed, and one of these goes to a ground pin, kind of to provide complete a circuit, so that when the button's pressed, we know the difference between ground, and these GPIO pins run at like 3.3 volts. And then we need the same thing for the red button, so that needs 2 connections to the Pi. And then up here, the TM1637, that needs 4 things. So it needs a power line, and we're going to connect that to Raspberry Pi's 5-volt power. So it's going to take 5-volt power from that. It also needs a ground connection, complete the circuit. And then it has 2 that are to do with controlling it. So I'll draw those in blue. So it needs a clock and it needs a data pin, and they both go to GPIOs on the Raspberry Pi, the same way that the button does. And then there's a protocol for controlling this. Luckily, there's a library for that for Python, so we don't have to worry about the protocol here. Makes it nice and easy. We just have to know which numbered pins here we've connected it to and which number pins we connected these to, so that we can address them properly in the code. And what the code's basically going to do is it's going to wait for one of these buttons to be pressed. So I'll either press this one, or we're going to set this one so it needs to be pressed and held to reset the count. And when that happens, it's going to run some code that will go ahead and update Redis here. And then that will cause the pub sub to happen from Redis. And we're one of the subscribers, so we'll get notification here, and then we'll go get the new value from Redis, so like 50 or whatever it happens to be. And then because this is pub sub off to the right here, all of our other connected interfaces, so the node interface, will also get that, and they should all stay in sync. So that's the idea here. I'm going to go ahead and get rid of the iPad here, because I think I say this every time, but it does cause the machine to go a bit crazy and you get a lot of fan. So we've got all of this set up. I can leave this front end running here. So there's the node output. I think I've still got another window for this somewhere. Yep. And they're still in sync, 47, 48, 49. So what we need to do now is take a look at, let's actually just run the code first and see it working on the Raspberry Pi. So I've got a Raspberry Pi on my second camera here, so we can add that to the stream. And as you can see, that display is actually set to the lowest brightness, and it's not dull here today. It's not bad, but these displays are really, really bright. So as with a lot of LEDs, you could perhaps diffuse them with something. So something that's like a sort of bit of smoke or car window tint or something. I've actually got the lid here for the case that the Raspberry Pi is in. So we could like put that in front of there, and you can see that that kind of helps a bit. But yeah, we'll run without a diffuser, and we can see it currently says 39. So this is just from when I was running it last time. The code's not actually running over here on the Pi. It's not running yet, but when I run it, what we should see is that that 39 jumps to be 49 to be in sync with the rest. So fingers crossed. Once we run it, yeah, there it goes. It changed to 49. So when it started up, it got the value from Redis, and it's now subscribed to PubSub notifications for that key. And hopefully, fingers crossed, this is where the live demos get stressful. If I hit increment here, what we should see is Node.js, or rather this front end, talks to a route on Node.js. Node.js increments the counter in Redis. Redis issues a PubSub message. Node.js consumes that and sends a server-sent event to both of these front ends, so they update, but also that Raspberry Pi down there updates because it's listening to the same PubSubs. So let's see if this is going to work. So I've got 50, 50, 50, yep, 51, 52. As you can see, it's reasonably real time as well. So all of that's happening every time I press this, and they're all going back to Redis to get, or at least Node and Python are separately going back to Redis to get the new counter value. And I'm running Redis in the cloud, so it's not running like here on my local network at home. It's running up in the cloud somewhere on EC2. So yeah, we have that working now. So 61, 62. Let's see if we can make the, there we go, make the counter a little bit bigger. And what you'll see here is I've got a green button connected to it. I'm having to be a little bit careful with where the camera is here. And that's basically a micro switch at the bottom. It's got, every time I press this, we get an event that happens in the Python code, 63, 64, 65. And if we go back to having the desktop here, and I press this, 66, 67, 68, 69, and now we can see everybody, 70, 71, 72, 73. So I've got this working from here. So I've got a button that I can press. it does the same thing. So it doesn't matter where the event originates from. And the Python code and the Node code don't know anything about the pub sub setup. So they're just incrementing a key. They don't know that there's a wider process going on here that updates things. They don't need to know that. So yeah, let's take a look at what is running here on the Raspberry Pi and how this is working. So normally I would sort of live code this a little bit more, or at least sort of, have played around with it beforehand and we puzzle it out on stream. But given I've been away recently, I not had the time to do that. So I kind of went ahead and did it. So here in the Raspberry Pi folder, we've got a counter.py, we've got a requirements.txt. Basically, we just need a library for the display. I've used a library for the buttons because they can be a little bit tricky to deal with. There's something called debouncing on these buttons that basically means determining when it's been pressed cleanly is a little bit trickier than it could be. So using a library for that helps. And then obviously we have Redis Pi, just the regular Redis Pi client. There's nothing special about running this on a Raspberry Pi. So if I look at the code here, and let's see if we can make this a bit larger too. Let's make it a lot larger. Let's get rid of this for the moment. So I've got some code here that what it does is TM1637 is a library for the display. So we'll look at how that works. GPIO 0 is a library for dealing with common general purpose input output things on the Pi. So turning LEDs on and off. It's got this great thing for helping with buttons that avoids the need to understand much about the debouncing problem. So we just basically treat these almost like we can clicks on a web page without worrying about the mechanics of how it determines whether something's been pressed or long pressed or what have you. Okay, so what I'm going to do to start with is I have to remember we wired that TM1637, that display there. It's got, I don't show it. It's got those four colored wires going to the Raspberry Pi. So everything there that you see is non-white. The black one is ground. The red one is 5 volts. And the green and white ones are the clock and the data. So those are the two that this library needs in order to, let's get this back where we want it, in order to drive this display. So we just have to tell it where we've attached those. And these pin numbers are, the Raspberry Pi has a layout. They're all numbered for those. If you're interested in what they all do, take a look at, let's do pinout.xyz. So this is a fantastic site that shows you what all of those pins do. And also, if you've got some Raspberry Pi accessories, so hats or other plug-in devices like the LEDs you've seen me use before, you can find which pins those actually use from this site too. So in this case, we can connect to anything. So I've gone with, what are we connected to? 23 and 24. So these here that are GPIO pins. And then I've also connected it to a 5 volt power and a ground. So those are the things that the display there needs. And then I'm setting it to like the lowest brightness, and that's how bright it is. So this thing can get very, very bright. Then my other parts of my front end are 2 buttons. So those buttons are both hardware. We're using the button class from the GPIO 0 library to model those. And I'm saying that I want to trigger a button event whenever something connected to GPIO 16, so that's my green button, is held down for like 0.1 of a second and then released. And I want to use the reset button, so the red one, I've attached that to GPIO 11. These are pretty arbitrary choices. And I'm saying, let's have a longer press on that. So tell me about it when it's been 2 seconds. So you can increment the counter easily. If you want to reset the counter, which erases the key in Redis, then we're going to make you hold on for a little bit longer and do that. So let's have a look at 16 and 11. Let's just go back to pinout here. So you can see that we've got, where are they? 16 there is down the bottom. And where's 11? Over here. And the buttons also need connecting to ground. So I've picked ones here, look, that are next to ground, because what you'll notice, well, maybe, is that on this end, I've used connectors for the buttons that already have a connector. So they have two wires that are kind of forced into this one connector. So I needed the grounds next to the GPIOs for that. But yeah, you could take that apart. You could use just jumper wires like I used for the display and put them anywhere. But conveniently, a number of these GPIO pins are next to ground, so that you can plug in something that needs a GPIO and a ground using one of these easier connectors. So we did that, and we've got all of those set up. And then let's see what we do now. So we need to show an initial count value. So I just set the count to 0 to start with, and we'll show that. And oh, hang on, this is old code. This is very old code. Let me just update this. Sorry about that. All of what I've said so far is valid, but there's nothing that actually counts the that talks to Redis in there. So let us. The new code is, of course, on the Raspberry Pi, but I also put it in GitHub. Hopefully, when we do this, that's looking better. Yeah, we get all of this extra counter code. Sorry about that. Right. Let's come back to here. Oops. Or rather, let's come back to a new tab and let's start VS Code here again. That's better. Right. So we've got about the same thing. We've got the setup for these buttons and we've got the setup for the display that we had before. So what we're going to do is we also need to talk to Redis. So I'm importing Redis. This, as I said, is just regular Redis Pi. It's not anything special to the Raspberry Pi. It's just a normal client for Redis. And I've put some secrets in a .m file, so I'm loading those. That's just my my URL to connect to Redis in the cloud. So I'm going to connect to Redis, so I get a connection to Redis. And then similarly to the Node code, I need a blocking connection for doing other things. And the way Node Redis does this for PubSub is it has a PubSub function that returns a different client. And it can tell me all sorts of things. So I'm not interested in when things subscribe and unsubscribe. I just want real events. So I can tell it I don't want those. We didn't have to turn that on and off in the Node code because it doesn't have that behavior by default. But in Python, we're telling it we're not interested in those. So then here's our setup that I was talking about before for the buttons and the display. And then similarly to the Node code, we need a key name in Redis that we want to interact with. So we're calling it myCounter, the same as it is everywhere else. And then we basically want to talk or listen to the same Keyspace events. So the same PubSub events, __ Keyspace at 0 __ colon the key name. So then this is going to look kind of like the Node code, but it's not a web application. So there's no routes here. We could easily make this a Flask application and have something like the Node code. But here we're using the hardware. So whenever the reset count function gets called, all we do is tell Redis to delete the key. So that's the same as setting it to 0, which is going to remove it from Redis. And then when the incr count function is called, we're going to use the incr_by function and say add 1 to whatever the current value of the count is. Similarly to the Node code, we could get back the new value of the count here, but we don't actually care about that because we're going to deal with that through PubSub. Then we just use the button interface that we've got here, and we just attach callback. These as callback functions to each button. So the count button, when it's held down for however long we said, so like 0.1 of a second, it's going to run this code here. And the reset button, when it's held for a couple of seconds, it's going to run that code there. And that's what you'll see happen when I do this, 74, 75, 76, etc. And when we start up, we need to initially show some value for the count. So I'm just basically doing getting the count from Redis. In the case where we've just reset it and there is no key there, then we'll just assume it's 0 because nobody's written anything to it yet. And in order to display it, this library makes working with the display really easy. We don't have to work with the protocol for it or the timing or anything. We just do tm.number in this case because I want to show a number. And then I turn that count into an integer. And I could do something fancy like add leading zeros perhaps and not use a number. It's got a string writing function, but I just went for the easy option. And rather than 0076, we just have 76. So that sets up our basics and that allows us to do this. So 77, 78, 79. I don't know if you can hear the really satisfying micro switch on here. These were actually pulled from an arcade machine in a previous job. So they've had quite a lot of use in an arcade machine, and these things are basically indestructible. They're fantastic and they sound really satisfying. So that's our basic getting something up and running counting mechanism. Now, how do we update the display? Well, we use the same path architecturally as we had in Node. So we're going to listen for pub/sub messages, and we're going to be told that the key changed. And then we're going to get the value of the key, and we're going to put that on the display. So here I'm using this other Redis client, so the second one, to subscribe because it's going to get blocked for a while. And what I'm doing here is, this is kind of a nice generator type interface that Redis Pi has for this. So I'm basically just going into a loop forever, listening for pub/sub messages. And whenever one happens, I'm doing the same as in Node. So I'm assuming we have a count of 0. And if our pub/sub message has a field called data, and that data field is increby, so Redis tells us what command was run on the key we're interested in, then I'm going to go get that count. I'm going to go get the new value, and I'm going to make it an integer rather than a string, because my function down here to display it needs an integer rather than a string. And if it's a delete message, then I'm not going to do anything because we already set the new count variable to 0 up the top there. But I'm just going to print out that we reset it to 0, and we are going to update the count with whatever the new value is. And that's literally it. So there's like 53 lines of Python, including all of these imports. Don't even need that one anymore. I don't know why that's that. So I'll tidy that up later. So yeah, what you can see here is we could deploy this to multiple Raspberry Pis, and that's something that I want to look at in future on this stream, is how we manage like pushing lots of software out to Raspberry Pis. It's not a Redis specific topic, but I think it's an interesting thing to try on this stream. We could have multiple turnstiles or whatever things we want to model and push software out to all of them. So if I go and switch back to the counter here and bring up the other instance of the counter, and what you can see is we've got 90, 90, 90. If I hit reset by pressing and holding the red button here, you'll see it's gone to 0, went to 0, went to 0. So our reset code works. So what does that mean in terms of what's in Redis? What it means is if I come here and do a refresh on this, the database is now empty, so there's no keys to display. So basically having no value is the same as 0. One of the cool things about Redis is you don't need many setup commands. So the first time I go to increment a key, doesn't even matter if it doesn't exist. I can just call increment, and if it doesn't exist, Redis will go, oh, that doesn't exist. Let's just assume an initial value of 0 and add 1 to it. So I can come back to one of my interfaces here. I can do increment. You'll see I've got 1, 1, and down there on the Pi, we've got 1 as well. So even after I've deleted the key, those pub/sub subscriptions remain valid. It's just, it won't do anything until the key is recreated. And then when we recreate the key with a value of 1, out comes a pub/sub notification. Node goes and gets the value of the key and sends server-sent events to these interfaces that are watching. Python does the same and updates the display, and everything stays in sync. So I'm then back to, I can press the button over here, 2, 3, or I can press the button on this one, 4, doesn't matter, they're all in sync. And what you'll see when I go back to here is my previously empty database. If I refresh the Keyspace, now has my counter again, and it's got a value of 4. Also, all of these are atomic. So at the minute, we're incrementing the value by 1. So, or it doesn't really matter what we're incrementing it by, but the point is all of our interfaces are incrementing by the same value. If we had some sort of like priority where if I press the button down here, it added 10 for some reason, because I was maybe like a group entrance to a turnstile, or I was some sort of bonus points generator, then you'd want all of these things to stay in sync and work properly. And because these operations are done atomically in Redis, that's okay. So if multiple people are hitting these interfaces, or we have multiple Raspberry Pis and we're pressing these buttons and they're adding different amounts, it's all going to figure it out in the same, it's all going to come to the same total. And that would be true if we were doing additions and subtractions, so we can increment by a negative number. And it all stays in sync. So yeah, this has been kind of a relatively short project. It does need a bit more of a write-up, so I will try and spend some time on excuse me, writing that up. As you can see at the moment, if we find the right window, we're a little bit light on readmes in here. But if you go to the URL here, you can get the code and take a look at it. If you want to get the equipment that I've got down here, you can get Raspberry Pi from various resellers. They are kind of hard to get hold of at the moment, but keep trying. The TM1637, the display there is pretty easy to get hold of from almost anywhere. They're all called TM1637. You don't need these extra 4 pins on here to chain them. 4-digit one's fine. Arcade buttons you can get from also all of the maker places. Some of them have LED lights on as well, that are kind of cool. So they're both an input and an output. I love using those for projects, and we'll get them on the stream at some point. But for this one, I just wanted the good old, like, super industrial, clicky, will last forever. Yeah, so that is, I think, about it for today. Relatively short stream, as I say. So what else is going on? So we always have Discord here. So you can join our Discord at discord.gg/Redis. We would love to see you there. You talk about anything Redis. You can promote projects you're doing. You can promote jobs that you've got if they're Redis related. And you can also get help with all of our courses. So we have Redis University at university.redis.com. There's 9 courses at the minute, and we currently have a 10th that is in production. So if you're a .NET developer, then go ahead and sign up for what we've called RU102N, Redis for .NET developers, and we'll let you know when that's available early in the new year. It's currently being worked on by Steve, our .NET advocate. So yeah, what else is happening? We have upcoming events this week. It is Thanksgiving week in the US, so a lot of our folks who are based there are not in work for the next couple of days. However, we will still be running Redis University office hours on Discord later on today. And tomorrow we will be running This Week on Discord, which is a show where we talk about everything that's happened this week on the Discord server. We look at some questions that people have had, and we answer them for them live. And don't feel bad about asking a question that will then sort of say, oh, this person asked this question, it was really basic. There are no bad questions. And we also make sure to redact your user information. So yeah, we just talk generally about things that are going on in Discord, and how we were able to help people out, or even better, how the rest of the community was able to help people out. So yeah, that's what we've got. One sort of last look at this, because I really like it. I can press a button and a number gets bigger. That's kind of a fun demo. Hopefully I can take this on the road at some point with a few of these and hopefully I can use the smaller Raspberry Pi Pico, so the one that you've seen me use in previous streams, because those are more easily available. I think the reason why I didn't use it for this project right now is I think the Redis client I was using didn't support PubSub, so I might have to see if I can enhance it to do that. But if I could do that, that would be great, because it would get the cost of the hardware for this project right down and put it in the realms of something that you can buy a Pico W, the Wi-Fi one, off the shelf right now, as many as you want. So, not subject to component shortage. In case you were wondering as well, I was using a Raspberry Pi 3 for this demonstration, but there's nothing special about that. Anyone with like GPIO headers will work fine. So if you've got a Pi 0 W with Wi-Fi, or you've got a Pi 2 with a Wi-Fi adapter, or a Pi 4 or the original Model B, all of those are fine. You don't need a specific number of GPIOs. The older ones had fewer, the newer ones have 40. We're using way less than that for this project. So yeah, and if you're interested in this sort of stuff, please do come chat with me on Discord. There's an Internet of Things channel there on Discord that you can join. And also, I have a live stream next week, and I'm going to need a new project. So I would be interested in your input on that, subject to me being able to get or have whatever hardware we need to do with it. Then yeah, we'll do that. I'm hoping to, at some point in future, maybe the next project, we'll see if I can think of an idea for it, look at something called Node-RED, which is like a graphical way of working with Node.js code, and you sort of put things together in a graphical like flowchart builder, and it passes messages from node to node. There's a Redis adapter for that, so hopefully if I can think of something, I will maybe look at that. Can't promise that will be the next project, but it'll be one in the near future. So yeah, I'm back a week from today with this show. I'm back tomorrow with This Week on Discord, and this afternoon on Discord with Redis University Office Hours. So hope you're having a great day. If you're watching this on Thanksgiving in the US, have a good day. Go do something non-work related and eat lots of food. And we'll see you next week. All right. Thanks, everybody. Bye.